All right, so in this example, we are looking at presidential election polling, and we want to know how large of a sample of voters do we need if we want a 90% confidence interval for the true proportion of voters that plan to vote for the Democrat candidate, and we want that confidence interval to be accurate to within 2%. Okay, so reading this, we've got some clues about, what are we trying to find? What do we know? How large of a sample of voters do we need? Of course, that is telling us find N, right? Find our sample size. Okay, so what else do we know? Well, first off, we're looking for proportion, right? We want 90% confidence, and we want it accurate to within 2%. So those give us some information, right? 90% confidence means we're going to use, for proportions, a z-score 1.645, right? The to within 2%, that's telling us the margin of error, right? So 2%, remember to put that as decimal. And so we know, since we're trying to find sample size, we know that our formula for that, for proportions, z squared, p hat, q hat, over margin of error squared. And of course for this one, we say, well, I think I used all the numbers in this problem, so what is p hat? So since we have no estimate for it, we are going to use 0.5. That's our probability, our proportion of successes, right? Probability of success, which in this case would be voting for the Democrat candidate. And our Q hat, remember, is 1 minus P hat. So 1 minus 0.5 also equal to 0.5. So from this point on, we are looking at plug and chug, right? 1.645 squared times 0.5 to P hat times 0.5 Q hat, and divided by margin of error squared, 0.02 squared. And so we just need to put this into our calculator. Let's see here. There we are. And find out what it is, right? 1.645 squared times 0.5 times 0.5 divided by 0.02 squared. And of course, you don't really need those parentheses that I had put in to make it divide the whole thing because this is a product. Now I'm on GeoGebra Classic, and it's giving me the fraction. If I hit enter, I'm going to be able to do the decimal approximation. So 1691.265. Now, of course, that is not a good answer because we can't interview or survey 0.26 of a voter. We need to round up always, right? For sample size, you break your rounding rules, you're going to round up. So because if we round down, our margin of error might be a little bit too big, right? Might be a little over 2%. It's okay to be smaller than 2%. We really don't want to be over 2%. So we are going to sample 1,692 voters.